the next step here is to do what's called combine like terms. So you're looking for whatever has an x squared, and you take with it the operator. So if there's a negative out in front, it goes with it. If there's a subtraction out in front, it goes with it. And you've got to combine these two things. What is minus 5x squared minus 8x squared? You combine those together, that's minus 13x squared. And then you grab your next term, you're like, okay, it's plus 4x. Again, I'm taking that operator with it, plus 2x. And you combine those. They're both positive, so you keep the sign, plus 6x. And then the last one here, you get minus 2 and plus 1. Again, the reason I grabbed the operator is that you should end up circling or combining everything. Minus 2 plus 1 is minus 1.
Yeah.
Okay, any questions on that?
No, is that all you do for that one?
Yeah, and that's, I mean, that's a nice one.
Yeah.
We'll look at another one here because sometimes not everything combines. Like it's not the case that everything combines nicely. We'll see that here in the next one. So again, because there's a plus in the middle, there's really no reason to have the parentheses, but I'm not going to rewrite it because it just takes too much time. So when I circle this 8x to the fourth, do you see that there is no other power of 4 term?
Yeah.
So you just bring it down, 8x to the fourth. Okay. And then you could go to the 2x squared, but you really want to go in descending order. Okay, so see how there's no other cubed terms. There's only one with a power of 3. I know it's hard to see. So that's plus 3x cubed. But you just keep going down in power here. So plus 2x squared minus 5x squared. So those actually cancel. Another approach that students use, I don't like this one as much when you're first starting out, but it's good on a test, is you cross them out when you're, oh, I'm sorry. I'm not reading that. It's plus 2 minus 5. It's minus 3x squared. I apologize for that. But what some students do is they like to cross them out as they combine them. And I think that's a useful thing to do.
Yeah.
Plus 7x. So you bring that 7x down. And then lastly, you've got minus 1, plus 1. Those completely cancel out. So you don't have to write anything. I mean, you could write plus 0. I don't know if your instructors would care, but you could do that. So the plus 1 is super easy. It's actually on SAT exams, ACT exams. Sometimes you see a plus question, but that's, you're not going to see that on your test most likely. You're going to see a subtraction question. So let's look at number 10, unless there was another in that grouping that you needed to do for homework.
No, we're good.
Okay. All right. So this is problematic. You've got a minus in front of the parentheses on the right. Now notice what's not written out in front of the left. There's actually a plus out in front of the left, but it's not written. If there's a plus, you don't need the parentheses. But when there's a minus, you have to distribute that to everything inside, and you essentially just change the sign. You change the sign or flip the sign of everything. So it'd be minus 2x to the fourth, minus 3x cubed, plus x squared, minus x plus 4. Super important that you distribute to everything. You don't miss anything because it affects your answer. And then you bring the previous one down. I didn't write that very well, but now you just combine like terms like we've been doing. So that's 7x to the fourth goes with the minus 2x to the fourth. And then you just go down in descending order, like from tallest to smallest. So minus 9 and minus 3, minus 12x cubed. Minus 4x squared plus x squared. So that's minus 3x squared. And you just keep going here. I run out of colors on this pretty quickly. Plus 5x minus x is plus 4x. And then, if you don't, and you wouldn't have colored pencils on your exam probably, so you can do other things like you can underline,
Mm-hmm.
you can overline, double underline, you can box, you can do anything you want. The point is to not miss any, if at all
Yeah.
possible.
That's what I've been doing on my paper. I've been doing like a circle or like a square and
Yes.
then underline.
Yes. Yes. Okay, so why don't you try number 12 on your own? And let me know when you come up with your final answer for this one. It's the same as 10, you just different numbers and different things. So let me know when you come up with something for that.
Okay. Okay. I don't know if I did this in the right order.
Okay, so the instructor may say, remember how last time we talked about that whole like a plus bi and it had to be in that format? They may
Yeah.
say like, hey, it needs to be in descending order. So you have to do the x to the 5th first.
Okay.
And like, do I care? No, I don't care. But your instructor might, because they're
Mhm.
grading you. So, but whenever you're ready, go ahead and give me your answer in whatever order.
Okay. So I got negative 10x to the 5th
Okay, I agree with that.
plus 8x to the 4th
Okay, I like that.
minus 7x cubed
Minus 7x cubed, good.
and then minus 20x squared
Perfect.
minus x plus 18.
You got it.
Okay.
Is this difficult?
No.
It is not. It is not. If you're patient, if you're very detail oriented, you will do these problems. These will be very easy for you to do.
Yeah.
All right. Let's see here. Let's look at, I'm ready to move on to 18 to 20, or grouping 17 through 24. But you tell me if you want us to do another one in 9 through 14.
No, you can move on.
Okay. All right. Okay, so 17 through 24, it says to find the product, determine the product. And it's actually kind of a lot like what we just did. You have to take this whole thing on the outside and you distribute it to everything on the inside. Okay. So as a reminder, a number times a number gives you a number. Okay. But if it's like x to the 5th times x cubed, when the bases are the same, you add the exponents. Bases are the same, you add the exponents, because you're going to be doing a lot of that. So we want to get that, that down.
Okay.
So, and this is what you don't want to do, but this is what you want to visualize writing. Like you don't want to write this out because it's very slow, but that is essentially what you're doing. You're taking the 4x to the 5th, negative 4x to the 5th times 11x cubed. Okay. Then you're taking minus 4x to the 5th times 2x squared. Then you're taking minus 4x to the 5th times 9x. And then lastly, minus 4x to the 5th times 1. So that's what you're doing. You're literally doing that. I don't want you to write this down. It will become burdensome on tests and quizzes. You have to be comfortable taking that like -4 and multiplying by 11, -44. And then x to the 5th times x cubed, you add the exponents x to the 8th. Then you keep going here. That -4x to the 5th times 2x squared becomes -8x to the 7th. Then you got -4 times 9 minus 36x. Now, if there's nothing written, it's really x to the 1. So that's x to the 6th. And then -4x to the 5th as your closeout.
Yeah.
Any questions on that?
No.
Let me make one up here for you to try. So let's go -3x to the 4th times 12x cubed minus 15x squared plus x plus 2. Go ahead and try that for me, please.
Okay, I got oops. -36x to the 7th
Okay, good.
plus 45x to the 6th. And then -3x to the 4th.
5th, because there's really a 1
Oh,
there. Yeah.
yeah. And then -6x to the 4th.
Good. Good. Very good. Okay. So that's pretty clear. When there's one thing on the outside, it's you multiply in, no big deal. So where we're going is there's more than one thing to multiply. So I'm going to look at a problem like 21. It's a good kind of starter question for this type of problem, this sort of generalized multiplying. Okay, so this generalized multiplying is, and I apologize, this isn't very interesting. I mean, it's like this is what it is. It's not, there's nothing exciting here, but you do have to figure it out for your test. So you take everything on the left. So I'll start with red for x squared, and you multiply it by everything on the right. Okay, so then you take that middle term, and again, I always grab it with the operator, and you multiply everything there. And then you grab that last one and you multiply it by everything. Hopefully you see the pattern.
Yeah, so you just multiply everything in the first parentheses.
Yeah. So now just you can just watch here, because I think there's something you're going to see here by the way that I do it that may be different than what you see in class. So x squared times x squared is x to the 4th. X squared times -3x is -3x cubed. X squared times -5 is -5x squared. Okay. So the next one, this -2x times -2x squared, here's what I do. I line it up in the x cubed column. I don't put it off to the right here, which is I think what you see in a lot of classrooms. And the reason is because I think it's easier to add vertically than to try to find them horizontally. So we'll keep going here. -2x times -3x is +6x squared. And then -2x times -5 is +10x. Okay, so we'll keep going here with the next color. We'll go with green for this. -4 times x squared is -4x squared. -4 times -3 is +12x. -4 times -5 is +20. And then I know we don't see this very often in Arizona, but this is a waterfall, right? Nice waterfall coming down. Maybe you've been hiking somewhere where there's waterfalls. I don't know.
Yeah.
But what this allows you to do, more importantly, is it's like if when I show 7 and 8-year-olds how to add, we add vertically, and that's why this method is preferred, because you're just going vertical now with your adding. Okay, so it's minus 5x squared plus 6x squared minus 4x squared is minus 3x squared plus 22x plus 20. You do not have to use this approach. I'm just but this is recommended. Like I would do it this way,
Yeah.
and there. All right. These are long problems. These are really time consuming.
Yeah.
So you don't get a bunch of these on the test. But we should we should look at one more together, and then we can move on to that other pieces of paper that you sent here. Okay, so we're going to start out here. And you could start with everything on the right towards the left. I guess I just always go everything on the left to the right. It doesn't really matter. You can pick, but it's 4x squared times x to the 4th. It's the first times the first. That's 4x to the 6th. 4x squared times 3x squared. Okay, that's 12x to the 4th. Now I'm going to leave a gap this time because I know there could be an x to the 5th term right in the middle here. So I'm going to leave a little space. 4x squared times 4x is 16x cubed. And I'm putting it there because I'm just going down in descending order. So then I'm going to take that minus 8x times each of the 3 terms. Minus 8x times x to the 4th is minus 8x to the 5th. Minus 8x times 3x squared is minus 24x cubed. So I line that up in that column. Minus 8x times 4x is minus 32x squared. And then continue. So minus 2 times x to the 4th is minus 2x to the 4th. Minus 2 times 3x squared is minus 6x squared. Minus 2 times 4x is minus 8x. And yeah, there's some gaps, but this is just an easier way to sort of line things up for me. So it's up to you. That's one of the benefits of getting this instruction on the side is you get a few other choices for how to work out problems, and you may find some things that help you there.
Yeah.
The most common mistake is when students don't multiply everything by everything.
Right.
So you can like cross out the 4x squared when you're done with that, cross out the minus 8x and so on. It really comes down to you getting, everything everything multiplied by everything. So if that is clear, if we've got kind of that all down, we can move to the other worksheet, which has got kind of some related problems here. So let me start with number 3. 1 and 2, I think you know how to do without question.
Yes.
But number 3. Okay, so number 3, the preferred way to do this is to write out what this actually means. Like if I asked you, what is 5 squared? You might say 25, but you might say, oh, it's 5 times 5. Okay, it's the thing that I'm squaring multiplied by itself. And that's super critical to do. You have to remember what is it that I'm actually doing here? Okay, so do you remember how to FOIL?
Yes.
Could you try foiling this for me, please?
Yeah. Do you want me to simplify it? Yeah.
Yes, please.
Okay, I got x squared minus 14x minus 49.
x squared minus 14x plus 49, because
Oh, yes, yeah.
negative times negative
Right.
makes it positive.
Right.
Okay, so if that's clear, let's have you try number 4 on your own here. It's another FOIL problem, and then I'll talk with you about how to do number 5. But go ahead and give that a try, please. It's another FOIL, and simplify as much as you can.
I got 4x minus 1.
It's 4x squared,
Oh yeah,
right?
4x
1
squared.
and 1, yeah. But it is minus 1. The outer and the inner terms cancel.
Yeah.
Okay, let's look at number 5 together. Okay, so this again, like the analogy is like, well, what is like 9 cubed? It's 9 times 9 times 9. So this is x plus 4 times x plus 4 times x plus 4. Okay, so what I'd like you to do for us is FOIL the first two. Give me that reduced answer whenever you come up with it.
So x squared plus 8x plus 16.
Yes, perfect. Perfect. Yeah. Now you bring the last x plus 4 down, and you take each of the ones on the left and multiply on the right. So x squared times x is x cubed. X squared times 4 is 4x squared. 8x times x is 8x squared. 8x times 4 is 32x. 16 times x is 16x. 16 times 4 is 64. Nice little waterfall there. X cubed plus 12x squared plus 48x plus 64. Okay, and you may be expected to do that on an exam. I'm not sure, obviously, because I don't write your exams. You occasionally see stuff on if you're on Instagram or TikTok, like, here's a shortcut for how to cube something like this. It is not helpful. You'll forget it. You'll just end up doing it the long way anyway. So just be prepared for that.
Okay.
Any questions on that before we move to 6 through 8?
No, I think I'm good.
Okay. All right. So number 6, I actually think number 6, 7, and 8 are pretty good problems here. These are they're more challenging than the ones we've seen thus far. Plus, they've got a lot of letters rather than numbers. That's always kind of a challenge for students. So it says when ax squared plus bx minus 1 is added to ax cubed plus 2bx squared minus 2x minus 1, the result is this next expression on the right. Okay, so they're telling you, though, they're saying, okay, we're going to add ax squared plus bx minus 1 plus ax cubed plus 2bx squared minus 2x minus 1. So when you add, you just write the two expressions next to each other, and you see what you can combine. You see what you can combine, all right? And then we'll get to this result here in a moment. So the first thing I notice is that there's an ax cubed term, but there's just one of them. Do you see that? There's just an ax cubed.
Yeah.
Okay. But now there's an ax squared and a 2bx squared. You see that? Plus ax squared plus 2bx squared, like this. We'll get to what to do in a moment, but we're just combining them together as best we can. So plus bx minus 2x. So plus bx minus 2x. And then that last one there, the minus one, minus one, minus one. So we can actually combine those minus two.
Yeah.
Any questions so far?
No.
Okay, so in the blue here, do you see that there's an x squared in both?
Yeah.
You can factor that out, and that leaves a plus 2b. But what's preferred is actually when that x squared is to the right of it, even though it's kind of awkward when in terms of your factoring, because you're used to it being on the left when you factor something out. And in the green, do you see that they both have an x? Let me know when you're if you're there, Isabel.
Oh, yes.
Okay.
So I was writing things down.
Yeah, no problem, no problem. And if I'm going too fast, just tell me to slow down, and we'll keep
No,
going.
you're good.
All right. So the green both have an x, so you write b minus 2 inside. But again, it's weird, but you actually put that x off to the right here. Okay.
Yeah.
And so let me just get all this down again. It's ax cubed plus a plus 2b x squared plus b minus 2x minus 2. And this equals, now we bring down the thing that's the result, the 3x cubed plus 11x squared plus 2x minus c. And I write big. I know you probably don't have this much room on your thing there, but let me know when you get caught up to this point, because this is the next step is pretty important here.
Yeah. Okay, I'm good.
Okay. From this point forward, you match things up. So if they're the same, they have to be the same on the left and the right. So it's ax cubed equals 3x cubed.
Yeah.
Okay, so if ax cubed equals 3x cubed, do you see that a equals 3?
Yeah.
Okay, no big deal. We can do this. Then you take the a plus 2b x squared, and that equals 11x squared. A plus 2b x squared equals 11x squared. You can think of it as the x squared's canceling. It's not quite right, but we can go with that. So the a plus 2b equals 11. But what is the value of a?
3.
3. So it's really 3 plus 2b equals 11. 2b equals 8. B equals 4. And that should be confirmed with the last part here. I guess we'll just keep going here with this. So we've got b minus 2 times x equals 2x. So b minus 2 equals 2. And yeah, that works because b is 4. 4 minus 2 equals 2. That works. Yay. And then the last part, minus 2 equals minus c. That operator has to go with it. Minus 2 equals minus c. If you divide by -1, c equals 2.
Yeah.
Any questions on that or anything that's unclear?
No, I think I'm good.
Okay. Okay. And that's a good solid test question. Because you can't just visualize, you can't just say, oh, here are the answers. You have to sort of work through it. But we'll move on to 7 now. So 7 is a difference problem. Okay, so now this is always the awkwardness of the English language. It says when this first thing is subtracted from, so you have to start with the from, 7x to the 4th plus cx squared plus 5x plus 6, and subtract bx to the 4th minus x squared plus 2x minus 4. It's easy to get those flipped and everything gets messed up.
Yeah.
So now you're going to distribute that negative to everything on the right, which means you're going to change the sign of everything. Okay, so now we're ready to combine like terms, 7x to the fourth minus bx to the fourth. And this time I'm gonna just do it in one step. It's 7x minus b times x to the fourth. Let me know if you need any clarification on that.
No, I'm good.
Okay. The next one is plus cx squared plus x squared. Now, what is the number in front of x squared that is not written?
1.
1. So this becomes c plus 1 times x squared.
Yeah.
Now, what's nice is that the next one, there's no more letters. It's plus 5x minus 2x. So that's plus 3x. And then the last one, plus 6 plus 4, plus 6 plus 4 becomes plus 10.
So how come like if you have 7x minus b, like the parenthesis, the red part?
I'm sorry. This is wrong. It's 7 minus
Okay.
b.
Okay.
Yeah, apologize. That's really bad.
No, you're fine.
You can downvote the video later. Oh boy.
Edit that out.
Unfortunately, it takes a lot of time to edit stuff out, so it's a total live copy here. So okay, so you're setting it to 5x to the fourth plus ax cubed minus 3x squared plus 3x plus d, and you match piece for piece. So you set that 7 minus b equal to the 5 because they both have an x to the fourth.
Yeah.
Okay, and then you set the c plus 1 equal to minus 3. Now, did I miss something? Because I don't see an x cubed anywhere. That must be 0. Okay, we'll get to that. And then, so you set the c plus 1 equal to the minus 3. And then you can set the 3x equal to the 3x, but it's 3 equals 3. And then the 10 equals the d.
Yeah.
Okay. And so go ahead and solve for b and c for me, please, and let me know what you come up with.
So c should be -4.
Yeah,
And
c is
then-
-4. I agree.
Yeah.
How
And then
about
b it should be -12 or
try again? Try again.
-2.
It's positive 2 because and this one's a little bit awkward because of where it is in the equation system. But when you subtract 7 from both sides, you get negative b equals -2.
Yeah.
You have to bring that down, and then you undo the negative to get positive 2.
Oh, okay. So whenever it says -b equals the number, you
Yes.
flip the sign.
Yes.
Okay.
Okay, and that leads us to this really awkward thing here. What is a? A is 0 because it's not part of the final answer. There's no x cubes. So like what maybe what we should have done here is wrote a 0x cubed. But I guess more generally, if one of the coefficients doesn't match up with something, you should probably check your work, but it could be 0 is the point of this question.
Yeah.
All right, I'm gonna look. We're gonna go to 8 next, but we're just looking ahead here. I want to see what else you've got. Okay, the rest of this, I see what we're gonna do. Okay. All right, number 8. The expression ax squared minus bx plus 25 is 3x minus c times greater than 3x minus c. I think the language here is a little bit confusing. Times greater means to multiply. That's what you want to encode. Times greater means to multiply.
Yeah.
So multiplying, they're telling you to take 3x minus c and multiply by 3x minus c. So we're going to FOIL this. And you can FOIL it even if there's no number. Your first times your first is 9x squared, right? Because
Yeah.
that. Now your outer is 3x times minus c. So it's minus 3xc. When you have two letters, you just squeeze them together. And then you do the inner, which is also minus 3xc. And then you do the last times the last, which is plus c squared.
Yeah.
And you combine the outer and the inner. So it's 9x squared minus 6xc plus c squared. Now you could also write it as minus 6cx. That would also be okay. And we're setting this equal to ax squared minus bx plus 25. So we're going to set the 9x squared equal to the ax squared. So that means that 9 is equal to a. So you basically leave off the x part. Then we're going to set the minus 6cx equal to minus bx. So you have minus 6c, you don't need the x, equals minus b. So not great at the moment because there's two letters in there. And then the last one is c squared equals 25.
Yeah.
So from these three equations, the first one's already solved for. Hooray, we've got that down. For the last one, there's actually two solutions. I don't know if the instructor meant this, but when you take the square root of both sides, you get plus or minus the square root of 25. C is either plus or minus 5.
Yeah.
Now, the reason that matters is because that affects the value of B. Okay, so if you cancel the negatives on both sides here, you get 6c equals B, or B equals 6c. 6 times c. So if c is positive 5, remember we were solving those systems of like a quadratic and another quadratic, and so there'd be two solutions. That's the case here.
Yeah.
B is either 6 times 5, or B is 6 times negative 5. So it's either 30 or negative 30. Might be good to bring that up with your instructor just to sort of ask, is this what you intended, or is this, is this what I should expect? Because it's obviously, a little bit different than maybe what you're used to.
Yeah.
Okay, so 9, 10, and 11 are kind of, they're almost their own lesson. So I'm going to move to 12 because we won't even have enough time to finish one problem. It'll be very confusing. So we'll start with 12. We'll talk a little about 12 and 13, then maybe get into it. Okay, so when you look at 12, there are to answer questions about end behavior, there are two pieces of information you need to know. The first is you need to know the degree, and then you need to know the sign of the leading term. So do you know, can you tell me either of those for this one?
The sign should be positive.
Yes, this one is definitely positive. It's actually positive 7, but it doesn't really, the 7 doesn't matter. What about the degree? Any idea for that?
I don't really know what degree, like what they mean by that.
So the degree is the highest exponent.
Oh, okay. So it'd be x to the fourth.
Yeah, just 4.
Okay.
Okay, so there's 2 possibilities for degree. It's either even or odd. And then for the sign of the leading term, it's either positive or negative.
Yeah.
Okay, so we're gonna come back to this problem, but there are 4 graphs that you need to know. Okay, so the first graph here, or first 2. So these are both for even degrees. So there's 2 types. Either it and think of a quadratic. Remember how quadratic is U-shaped?
Yeah.
So it either opens up or it opens down.
Right.
Okay, and so how do you decide between the difference? It depends whether the leading term is positive. So the leading term is referred to as A. This A.
Mm-hmm.
So here's what you're looking for. If A is greater than 0 or positive, it's the one on the left. If A is less than 0 or negative, it's the one on the right. And I'm not sure if you've seen this in class.
Yeah.
Okay, now for each of these, there's an end behavior statement. So for the one on the left, you say as x goes to infinity, and it's actually referring to this one on the right here, f of x goes to infinity. And then the other one is when you're going the other direction, as x goes to minus infinity, f of x goes to positive infinity. Now, hopefully your instructor isn't flipping these. Textbooks flip these, and it's very confusing because you always start with x and then y. So I apologize if this isn't the way you've seen it, but this is really much easier for you to understand. So that, like, think of the f of x as the y's, and the x is ones for the right and ones for the left.
Yeah.
So for the one on the right here, it's the same thing as x goes to infinity, but now f of x goes to minus infinity. That's this one on the right here, because it's going down. And then this other arrow, as x goes to negative infinity, f of x goes to negative infinity.
Yeah.
Okay. So it feels like a lot. There's patterns here though. You're not actually memorizing all this. It's like if you can draw the arrows, then you can figure this out. Okay. But there's 2 more graphs for odd functions, or for odd powers, odd degrees.
Yeah.
So I'll get those up here for you, and then we'll be able to do the last 2 problems. So and think of a cubic. A cubic starts low and then ends high. And then the other possibility is it starts high and ends low. So these are both for odd powers. So the nice thing is there's only odd and even powers. You don't have to, there's only 4 graphs. This is if A is greater than 0, positive, the leading term. If A is less than 0, negative, leading term. And then you have 4 more of these statements, 2 for each. As x goes to infinity, f of x goes to infinity. That's the one on the right here, the top right. And then as x goes to negative infinity, f of x goes to negative infinity. And then on the left, I'm sorry, on the right here, as x goes to infinity, f of x goes to negative infinity, x goes to negative infinity, f of x goes to infinity, positive infinity. Okay, so when you know these graphs, I know it's a lot there, but these problems are very straightforward. You're like, oh, it's even and it's positive. So that means it's the one on the left here. You're like, oh, it's this graph right here. And then you write this stuff down. So in terms of your answer to 12, it's this stuff here on the bottom.
Yeah.
Okay. All right. And if you got that down, we can move to 13, which is slightly different, but it's kind of in the same category. So for 13 here, you might think, oh, I need to multiply all of this out. And that seems reasonable, but you don't need to do all that. You need to recognize that at some point you get x times x times x, which makes x cubed. But then do you see how this negative comes out in front?
Yeah.
So that's the leading term. You only care about the leading term because you need the degree. The degree is 3, which is odd. And then the leading coefficient is negative. So there's the information you need. It's odd and it's negative, and you go back and find the graph that matches with it. Oh, it's this one. This is the one for odd powers, and this is the one for the negative. And you write this stuff down for your end behavior. We went a little fast through that because of the time, but it's not as complicated as maybe they make it seem. It's fine. There's 4 graphs. You find the one that matches your information.
Yeah.
All right. Well, thanks for great job today. It's tough doing 50 minutes late at night, but well done. I'll send you the notes here shortly. And I know we don't have anything scheduled, but you probably need a little bit of time to get through the other problems here. So hopefully I'll get a chance to help you with that in the future.
Yeah, I'll probably end up scheduling one like maybe Sunday or something like that.
Sounds good. I hope you have a great rest of your week, and I'll see you next time. You're welcome.
You too. Bye.
Bye.